Hi, so this lesson, this recording is going to be a pretty short one because the goal of this lesson is to make sure you know how to write expressions both in radical form and with rational exponents. So we're going to start by looking at these expressions that are written in radical form. And we're going to write an equivalent expression using exponents. So we're going to start with square root of 5. Now, you don't always see this little 2 out here. Usually you don't see it. Usually it just says square root of 5 without the 2. This 2 is called the index. And then the number that's inside the radical also has an exponent, even when it looks like it doesn't have one. And so if the number is 5, that means it's really 5 to the first. Now, changing this from radical form to exponential form is actually quite easy. All we have to do is we keep the base 5, and then we're going to use the exponent that's on the inside and the index that's on the outside and create a fraction. The exponent goes on top, the index goes on the bottom, and that's it. So 5 to the first power, if we take the square root of that, can be written as 5 to the 1/2. All right, let's look at another one. Here we have the cube root of x. And remember, even though the x doesn't have an exponent, it does have an exponent of 1. We just don't always write it. So if I write that exponent in, now I can write it exponentially. I keep the x, that's my base. Then the 1 inside becomes my numerator, and the 3 on the outside becomes my denominator. And it's as simple as that. So let's try another one. So I've got x squared. See, this time my x does have an exponent that's written inside the radical. So take a minute, do it on your own paper, try it out. So I'm going to take the 2 that's on the inside as an exponent, that becomes my numerator, and the 3 that's on the outside becomes my denominator. All right, so now let's try this one. Now, this one we have to be careful with because this 5 that's inside is not an exponent for the whole thing. So this 5 just goes with the x. It's not 8 to the 5th. Only the x is being raised to the 5th power. So the 8 doesn't seem to have an exponent, and when something doesn't seem to have an exponent, remember it really does. It's an 8 to the 1st power. So now we can write this as 8 to the 1/2. Right? We take that 1, that's the numerator, 2 is the denominator. And then with the x, we have 5/2. Now, I'm not sure that that would actually be more simplified, but if we had to write it in exponential form, that's what it would look like. Now, in this next problem, this time we do have the entire thing being raised to the 6th power. So that means that we keep that as our base, and I'm even going to keep it in parentheses just to make it extra clear. And I need to keep it in parentheses because I want to show that not only is the x being raised, but the 4 is being raised as well to the exponent. Then this number, again, is going to become my top, and this will be my bottom. So I'll have 6 over 3, and that simplifies, right? So I get 4x. 6 divided by 3 is 2, and I can even keep going. That means 4x times 4x. So that means I have to square the 4 and square the x to get 16x squared. All right, and the last one on this slide. So the 27 doesn't seem like it has an exponent, so we write one in. And now all the exponents that are inside are my numerator, and the index number on the outside is my denominator. So I'll have 27 to the 1/3. And now you try the rest. I'm going to just pause and give you a chance to try it on your own. Okay, so you should have gotten x to the 3/3 and then y to the 2/3. They all have the same denominator. All the exponents have the same denominator because they all have the same index number out here. But now I can simplify this a little bit further because 27 has an integer cube root. So remember, I'm taking the cube root here. My index is 3. That means it's 27 to the 1/3. That means I'm looking for some number times itself that equals 27. So I want you to think for a moment. We're looking for some number times itself. That equals 27. Now you can use the cube root button on your calculator, but you should be able to think of this one. It's not a large number because it doesn't come out to be a very large cube. What number times itself, so we've got 3. Think about it. So hopefully you thought about the number 3, because 3 times 3 times 3 is 27. So what we had before, this part of our expression is just equal to 3. Now let's look at the next part. The next part, we've got x to the 3/3. So 3/3 can be simplified because it's x to the 1st, right? 3/3 is 1, so I would just get x. And then y to the 2/3, there's nothing really we can do with that, so we're done. Okay, so remember, we're just taking that inside index number, I'm sorry, not inside index, this inside exponent, and that becomes the top. The outside index number becomes the bottom.